I've been having difficulties with my 3D printer, which is a Anycubic Chrion or Chrion, and I always suspected that it's the glocking up of the actual nozzle is a result of small debris. But sometimes I do some light sanding around the desk where the printer is just over there, very close to where I work here. And yes, it results in you know, poor quality prints at best, and at worst literally no prints at all, or like you know, the whole thing is just not oozing normally. So I decided to take it apart, and I always do that. There is a lot of debris around this here. As you can see, there's a little bit there, and I actually managed to remove some of it just prior to making this video, and I just want to show you what I want to do to it, and hopefully this would work and you know, salvage this part, even though I was given the spare parts, which is the whole complete assembly of this, you know, manifold, nozzle, the whole shebang really. Could just like pop it back in there, and it only costs about, I think last time I checked, about £15 on Amazon. So you can just go ahead and buy a new one if you want to, but obviously if this happens every 15 days or something, you really can't, you know, buy a new one every 15, 20 days or a month. It's just gonna roll up to be a big cost. So what I'm thinking to do, which I just did, is literally take a small piece of wet wipes, preferably something that's not, you know, chemically loaded. Literally just cut a small tiny piece of it like that. And what I did is I took some filament, any type will do. In my case it's ABS black, and actually it's PLA. And literally just hold it in here, the end of this, make sure this is flat so it doesn't pierce through it, and try to wiggle it inside as so. Where is it? Oh, here it is. Yep, so literally in there. I keep pushing it, so what it's doing now, hopefully, is actually pushing all that debris, as you can see inside. You can tell that it's about there, and it's pushing all the debris, all the small chunks that you don't really need to be inside there, all the way to the end. And because the hot end meets this here inside the assembly, so literally this is inserted all the way to about there, and then it meets this one here, and then this goes there with the block being in between, you know, the heating block. So this stops about there, if you imagine this inside here. So this gets really hot sometimes as well. As you can see, I tried to push the filament. Actually with the cloth is never going to work anyway, because it's, you know, if you take out that now, hopefully the cloth will come out with it. If not, you can just cut it on the other side. There you go. As you can see, there's a little bit of dye. I actually went once before the video, so that's why it's got a little bit left, but not much. So I think it's clean enough inside. What I need to do now is to try with the Stanley knife, cut this tiny, about 10 mil off, so to give it like a fresh life, you know. So this is not really as, because I printed like PLA, TPU, I printed wood filament, so all those things, every one of those leaves a little shards or little tiny particles of their you know, chemical making, and it really messes up with the diameter of this, and that will restrict as well how much, you know, the motor is pushing the material through. If it's not to the diameter, if it's much smaller, it will actually stop the whole thing from oozing normally. So yeah, what I'm thinking to do is literally keep it as flat as possible, because I think that's important, because it needs to meet the inside of that like dead on. So if you cut it chamfered or something, it will actually ooze out, and it will probably block this, or like out of, you know, inside here. So as flat as possible. I don't know if I can make this on camera, but yeah. Here we go. I think that's flat enough. Yeah. As you can see here, as you can make the inside of it, look, it still has got a lot of, you know, actually quite big pieces. Yeah. So if I run this hopefully without the cloth first, just to push most of it out, and then we will try again with the cloth on. So all the way through until it comes the other side. Did you see that? It actually literally flew out, you know, because it didn't know when to stop. Yeah, there you go. So turn it around, hopefully. Yep. Out, and then cut a fresh small piece. And repeat the same. Well, always try to push it on the other side, you know, the main entrance, you know. This is the end of the nozzle, although in fact it doesn't really matter much now. You can still actually switch them, but I'd like to use this as a marker as to where to push this to meet the extruder, you know, motor. So yeah, that's like my guide here, and this one here is my guide on the other side. As you can see, there's a little bump here as to where to stop. You know, I have to reinsert this right in there. So hopefully now it's not going to stop there. It's going to go about like that 10 mil or whatever the length of this is to give me the new mark, you know, as to where to stop it. So yeah, carry on with the filaments all the way through. And there you go. As you can see, there is some debris that's still coming on the other side. Yep. Hopefully this will get rid of most, if not all, of the problems. The other thing that I did, which I played with for a bit now, and it seems to be working okay, because even though you're not doing any sanding at all next to your 3D printer, even if you have it in a nice environment like your house or your you know, workshop, or like even office, you still have that dust in the air. You know, if you see every household, unless you're actually, you know, making electronic components and it's super clean, every household, every workshop, every office have got a lot of, you know, tiny particles of you know, dust, and those, specifically with the plastic that we use, it gets statically attached to it, and then when it actually rolls over, not to mention that the roller itself, when it pinches through it, it makes tiny particles, or sometimes when it's cutting through it, when it gets stuck, and it pushes it all the way through inside here, and if it travels with it inside here and ends up on the other side and doing all this kind of like issues, which is, you know, burning of material that's not meant to be there, and glocking up the whole, you know, system. So if I wanted to put it back together, hopefully this will be yeah, the best way to do it. So as I said, this is my marker right there, and I need to go about, yeah, let's say it's like 8 mil. 1, 2, 3, 4, 5, 6, 7, 8 mil. Actually, I didn't know this, but you can't go any further than that. So they literally made it inside by the feel of it. That's like, you know, there is a step there for this to bottom down too. So you can't go any further. So you need probably to push it all, without crushing it obviously, pushing it all the way down. And once that in there, that's it. Just put the assembly back together and let's try it. I'm just going to show you what I have here. Just take the camera off the this. Literally before the sensor here, I put some felt. As you can see, it's actually felt that's sticking on the other side. So literally just cut the you know, the felt to suit. Literally have a small, like a T cut into it. So cut diagonally and just go slightly down, so the you know, the filament would be right in that tiny hole there. Before it actually goes through the system at all that will actually capture as much tiny hair and debris as it could. And as it goes inside there, this is what I was talking about earlier, as you can see, the wheel is sort of like, you know, there is all sorts of tiny particles here, some of which is actually, when that metal thing is pushing the material, it sometimes skids and literally just take tiny bits of it, and if it stays there, it will actually carry on the whole thing, you know, down to the nozzle, and then obviously it's gonna, you know, clog it up. So yeah, I'm just gonna put it back together and come back to you with the result as soon as possible. I hope you learned something of this. I hope I did, in fact, and talk to you later. Bye. Right, this occurred in the middle of a project of mine, so as soon as I tried this fix, I went back to CAD and finished the few parts that I needed to finish and used them as a trial. In fact, as you can see, I printed them and it worked fine, in fact, more than fine. I was impressed that the PLA could be used as a spring, in fact, would you believe it? So yeah, there we go.